All right, let's dive right in. Have you ever just stopped and wondered how a bunch of text typed into a file can suddenly make your computer do something? How does a simple written instruction become a real-world action? Well, today we're going to peek behind that curtain. We're going on the journey of a program, from code to action. And it all kicks off with something that looks a little like this. Now, if you've never seen it before, it probably looks like a secret code, right? Some kind of cryptic message. And honestly, in a way, it is. This is a simple program written in Java. Think of it like a recipe, but it's a recipe written for a machine. The question is, how does the machine actually read the recipe? And that's the big question for today, isn't it? How do we get from these very precise, human-readable words to an actual thing happening, like a message popping up on our screen? To figure that out, well, we need to meet the hero of our story.
And that hero has a name, the Java Virtual Machine, or what everyone calls the JVM. The best way to think about it? It's like a universal translator. It's this brilliant interpreter that sits right between our code and the computer hardware, ready to make sense of everything we've written.
You see, the really incredible thing about the JVM is that it creates this special, consistent environment for our code to live in. This means you can write your Java program once, and it can run on a Windows machine, a Mac, a Linux server, pretty much anywhere without changing a single line. The JVM is that essential bridge that makes it all possible, translating our code for whatever computer or operating system is listening on the other side.
So let's trace that journey. We start with what you see on the left, our human-readable source code. Now, a program called the Java compiler takes a look at it. But here's the twist. It doesn't translate it directly into the computer's native language. No, it translates it into an intermediate language called bytecode. This bytecode is the special language that only the JVM understands. Then, the JVM gets that bytecode and translates it into the final machine code that your computer's processor can actually understand and execute. It's a two-step process that makes Java so incredibly flexible.
Okay, so we know it translates. But, it's so much more than that. It's a busy manager, it's a security guard, and it's even a housekeeper, all rolled into one. So what is really going on inside the mind of our virtual translator?
Before a single line of your program actually runs, the JVM goes through this very specific pre-flight checklist. It does all this to make sure every program is going to run smoothly, efficiently, and maybe most important of all, safely. So let's pop the hood and take a look.
First up, it loads your code into the computer's memory. Then, and this part is absolutely crucial, it verifies the code. It acts like a security guard at the door, checking to make sure the code isn't trying to do anything sneaky or harmful. Next, it takes on the job of managing all the memory the program needs. And finally, it provides the actual stage, the runtime environment where your code gets to perform.
Now, one of the coolest parts of that memory management job is something called garbage collection. Seriously, you can think of it as an automated cleanup crew. As your program runs, it uses little bits of memory here and there. But once it's done with a piece of memory, the garbage collector swoops in, sees that it's not being used anymore, and frees it up so other parts of the program can use it. It's an incredibly efficient, automated recycling system.
Okay, so we've met the powerful machine that translates our code. But what about the code itself? What are the rules, the grammar? To really get the full picture, we have to go back to our original example and decode it. Let's learn to read the blueprint. So here it is again. I've added one tiny thing at the top. A little note just for us. Now let's break this down, piece by piece, and see how these different parts work together to build a complete instruction. In Java, pretty much everything lives inside of a class. See that line, public class test? That's creating the main container, the basic blueprint for our whole program. All of our instructions are going to be organized right inside of this. Then, inside that class container, we have methods. A method is just a block of code that does a specific job. And this one, public static void main, is super special. It's basically the front door to our program. It's the very first thing the JVM looks for when it's ready to run.
And where does the real work happen? In statements. A statement is one single complete instruction. That line, system.out.println welcome to Java, that's a statement. And its job is simple. Print the text, welcome to Java, to the screen. It's the verb of our code. It's the action.
So what about that new line I added at the top? The one that starts with 2 slashes? That's a comment. Anything after those 2 slashes on a line is completely ignored by the compiler and the JVM. It's just a note written by a human for other humans to help explain what's going on.
So now let's put it all together. We've seen the code, we've met the translator, and we've decoded the basic grammar. Let's do a quick recap of the entire journey, from our text file all the way to a finished action.
It all begins with a simple line of text, an idea that we've written down in a very specific language.
A language that has its own grammar, right? It's organized into containers, called classes, action blocks, called methods, and individual commands, called statements.
That text is then handed over to our powerful translator, the Java virtual machine. And the JVM checks it, manages it, and gets it all ready for the main event.
And just like that, after all those steps, that carefully written instruction becomes a real, actual thing happening on your computer. And that, right there, is the journey of a program.
And that really brings us to the final thought. It was just a single class, one method, and one statement. We made a computer talk to us. So if this is the kind of power we have with just the most basic building blocks, what will we build next?